Right, on this one, it still should be easy to find whether there's a maximum or minimum. Here, our leading coefficient is positive, so it's going to be a parabola opening up, which means the vertex is going to be a minimum point. And to find what that is, you do need to do one of two things. So you could find it by hand relatively easily. If you plot the x-intercepts for this, so the values of x that would give you zeros are the x-intercepts, right? So what value of x would give you a 0 for this factor? 3. So here's one x-intercept, and what value of x would give you a 0 for this factor? Okay, so here's your 2. You know that this graph is going to open up. Okay, and again, it's a little bit steeper than it would be from a general parabola because this leading coefficient is greater than 1. Okay, and so in order for you to find the actual vertex, you need to locate the x-coordinate of the vertex, and that's simply going to be the average of these x-intercepts. And so this winds up giving you a fraction, so it might actually be easier to use your calculator. We'll go through this in just a second. But you have a 3 and a 6. If you take the average of those, 3 plus 6 is 9 divided by 2 is 9/2. So you know that your answer has an x-coordinate, or your vertex has an x-coordinate of 9/2. So really, if you took this function and you plugged in 9/2 for x, and solved, you would get your value. Okay, so in this particular case, probably just as easy to have gone through, entered this in your y editor, 2 times x minus 3 times x minus 6. Go to our graph of this. Again, it should look similar to what I sketched here, which it does. Find the minimum value using the Math tab F5. Choose minimum. A lower bound of 0, an upper bound, again, as long as it's to the right of this intersection or this vertex. So I'm just going to use the number 9. I know that that's to the right of that. So the lowest point in that is 4.5 and then minus 4.5. So you see that your value is going to be negative 9/2, or again, negative 4.5.